Okay, multiplying by the conjugate. Yeah. So you got that old graphic organizer? Should we check it out? So check it out. 0 over 0. I have one tool so far. Factor. This is our second tool. We're going to rationalize by multiplying by the conjugate. Are these words you've heard of before? Yes. Well, you need a refresher, though. Medium. The conjugate is, so the conjugate of A plus B. What's the conjugate of A plus B? Anybody? A minus B. Good. A minus B. Excellent. Super. So, first of all, let's plug in, what do I get? Zero over 0. Which means, say it with me, do more work.
I thought you were going to say factor.
Well, that's one of, no, we have all these different options. We have a lot of different options. On your graphic organizer, it says do something. That's straight from College Board. That's their terminology. It's if 0 over 0, what do you have to do? It's italicized and bolded. Do something. No, for real. So this something is like factor. Is this factorable? No. So we're going to learn a new technique, rationalizing by multiplying by the conjugate.
Did you hear Michelle say cry? She did not say cry. We will factor or multiply or do something productive.
Okay. You ready? You ready? Okay. So the conjugate is, this is my A and this is my B. So I'm going to write it with a plus sign. Now, can I take a number and I'm trying to simplify a problem and figure out what it's equal to, and just multiply it by something? No, because that changes it, right? So this is not what is allowed. What number can I multiply by? Yes, 1. So if I put it over itself, then I can do that without changing the value. Yes. Does this seem a little bit familiar? We did this last year? Yes. Okay. Okay. Root x plus 1. That's good. Root x plus 1 times root x plus 1. Let's raise a hand. Just regular old x plus 1. What's going to happen when I do the outer? This is the outer and the inner. They cancel out. So do we have to do it out? No, we know they cancel, right? Because we had really good pre-calc teachers. Okay, so we know they cancel out. So this would be a positive root x plus 1. This would be a minus root x plus 1. They sum to 0. Minus 1 plus 1 is minus 1. That's the numerator. Let me give you a trick. You don't have to multiply out the side, like the top or the bottom. See how this is not the conjugate of that? You don't have to multiply it out. And if you do, you're going to have to undo what you do. So x. You might remember this from last year, for real.
Very much like trig identities.
Very much like trig identities.
It's giving me a lot of deja vu. I'll install it right now.
Yeah. So I multiply by a form of 1 with the conjugate over itself. When I do the thing times the conjugate, that one I do out. When I do the two random things, I don't do that out. Okay. So what happens? That cancels.
I'm getting hyped. You see?
Oh, I should still be writing limit. Oops. Limit as x approaches 0. Okay. I'm still writing. So when you plug in and you get 0 over 0, that doesn't really count as plugging in. Whoa, what happens? Do I see something?
practically jumping out of my chair here. Come on.
It's fine.
Yes, do you see it this time?
You can cancel the exes.
Yes! Fancy one. Yeah, awesome. Love it. Limit as x approaches 0. What do I write on top, everybody? 1. What do I write on bottom? Root x plus 1 plus 1. See why it's awesome that I left the bottom in factored form? Let's say I multiplied it out, canceling would not be so simple. I'd have to refactor it out again. After you cancel, go ahead and plug in. So, last couple steps. Substitute in the 0 now. Now I'm actually going to find the limit.
It's not gonna be 0 over 0.
It's not 0 over 0. Right in this step, that whole is period. So 1 over the square root of, I'm plugging in 0. 0 plus 1, big plus 1. The square root of 1 is 1 plus 1 is 2. 1 over 2.
You just turn 0 over 0 into 1/2. That's the magic, bro.
Okay, so also, like, yeah, would you have looked at this and guessed the answer was a half? No, like, you have to have this technique. So if you get 0 over 0, that means do more work.
Pardon the interruption. Sasara and Master Cola, please report to the welcome office. Sasara to the welcome office. Thank you.
So if you get 0 over 0, that means do more work, which means I have some techniques. Factor, multiply by the conjugate. Okay, so can you just turn to your neighbor and just summarize what we just did here? Victoria, you can summarize this, Denzel.
We turn
Take a little walk.
0 over 0 is 1/2.
What was the more work we did?
We multiply by the conjugate.
Okay. Why did we go for the conjugate instead of factor? Like here, I guess kind of obvious that the numerator not
How did I know we should
the
multiply by the
conjugate thing. But like,
Yes.
how would you decide
Why
which
did I need to make
conjugate
this
up? What do you look
huge
for when you say, oh, I can do conjugate here?
Correct.
Okay, that for sure. Like, if I'm looking at some new fraction, how would I pick the numerator or denominator to do that with? Like here, to the next one.
Turn to your neighbor now. What step do you think would trip you up? Like, where would you get stuck? Like, where's... Turn to your neighbor. Tell them.
Or they forget to use over 1. You don't really do
Multiplying it out. Yeah.
Yeah, or if you like, I would just multiply that into I would freak
And then be like stuck. Yes.
You don't multiply all the bottom.
So it's not correct, but it's not always the bottom. Like I could have reversed this problem. So see how these two are conjugates? The two that are conjugates multiply out. The other ones don't. So if this whole thing could have been flipped, and I still would have done these by itself together.
Could you do either? Yes, with mouse curves.
All right, we have another problem.
By doing the conjugate?
We have 11 minutes. You think we can figure this one out over the course of 11 minutes? I think we can.
I do.
All right, plug in 3. I get 0 over 0. Ah. Which means everybody?
Do some work.
Yeah, do some work. Okay.
I'm so
Which some options would be factor or multiply by the conjugate. Square roots are a really good tip-off for conjugates. Very, very strong tip-off when you see square roots for this technique.
Yeah, what else? I was trying to think as we were talking about. Square roots are really good.
That's it. Because we don't do imaginary things.
Yeah.
No, that's it. Just square roots.
Trig stuff, I did it before, but different.
Yes. Yeah.
I have a hard time with. I get why. I don't get like what's the G and the H for this.
Mm,
You know what I mean?
right, because they're not, one's not above the other.
Yeah. Like
Yes.
this. I get this reason in the sense that like maybe there's some easy functions that we know well, and here's some crazy complicated thing, and we can figure out
Yes.
things that
Right.
bound it. But like.
This is only one function, there's not like
Yeah.
two other,
Yeah.
you didn't like linearize it or something and then, yeah. I
I could
agree.
probably make something up where like, oh, we know what this thing does and we know what this thing does, and like, if we really think really hard, we can understand why, oh yeah, this one's always a little bit higher, but like,
Right.
yeah.
Yes. Yeah.
Oh, sorry. We just had that combo for all the athletes.
Because this would be 6 plus 2x. So I equals 2x. X equals 2x.
Yes.
That multiplier.
Okay, so x plus 6.
Wouldn't cancel out the x minus 3.
The outer and the inner go to 0. So outer and inner,
Oh, you just
0.
Mm.
But then, and then the last,
2 plus 3.
what's negative x times x?
I'm good here, you're here, and you're factoring. Yes.
Negative
So
x
you don't keep that one.
squared, right?
Oh,
But then it
oh, yeah.
Is this working out?
Hold on,
Is this
Yeah.
working out? Yeah.
hold on.
You're fine. The,
Wait. I'm not on this.
Oh, yeah, x plus 3 is true. Yeah, it's fine. Yeah.
I would
Go
take
on,
a negative now, or you can do it later.
Wait, pause. How's multiplying out the numerator? Okay, so far so. If you feel uncomfortable, just think we don't discriminate in here, even if you're square root in a denominator. I know that makes us uncomfortable. Sometimes we're uncomfortable with things, but it's okay. Square roots are just fine.
So it's gonna change this a little bit. So I still think it doesn't multiply out.
You didn't multiply out the denominator, did you?
To multiply x times x, you don't get negative x squared.
Yeah.
It's totally good. It's just a little weird.
Yeah,
It's
that's
negative x squared.
Yes. Because this is a number there. And then
And why do you
That's okay.
we did do that. We had too many ones. We had that makes 0, like that.
Oh, that makes sense.
Okay, let's join up. Let's join up. I'm not going to do the whole problem for you. Should we clean up the numerator? What are we thinking? Just do the squared term, put it in descending order by exponent. Negative x squared plus x plus 6. How's that? Yeah? X minus 3. Okay. Now, what if I were to say something in the numerator is making us uncomfortable? What in the numerator is making you uncomfortable about? Negative x squared plus x plus 6. What do you wish like wasn't there? Don't you wish the negative wasn't there?
They're not equal.
Yeah. So let's factor it out. Negative. You can stick it on top or way on the outside, doesn't matter. Oh, I'll put it on top, okay. X squared minus
It's not just
X. Then what? What do I write now? Minus 6.
This is the same, but you can multiply everything by -1. So this is the same, but that is not the same as this.
Okay.
So they got
Now is this like more happy to factor? If I just gave you the problem factor x squared minus x minus 6, you could do it. So do that. Told you it was going to. Yeah, so this x squared minus x minus 6 is going to get factored. So just leave the negative hanging out.
Outside.
The negative one out. Then you have to distribute.
So it's the same as this, you like distributed it. Yeah. And that one is
wrong with my calculator?
Calculator fixes that.
For the, you one? Yeah.
Ah.
Yeah.
It's just I need that, when I plug in 3. What?
It's
Oh, grab the shoe right. You agree with me, that it was conjugate.
You're gonna be in radians, so
No,
just.
because I looked at yours, I thought I was like, how? But then you thought,
All right, let me see the factoring here. Okay. Ooh, we have an answer.
Yeah, it's still there, So you want, basically, you want, remember, it's gotta be equal the whole time. So this
here,
is equal to that,
I don't know.
which is equal to that, which is this part in parentheses equals that. but
Oh, I
there's
still have the
negative
limit in
there.
front,
We
right?
want them all to be equal. Now we can do some canceling, right? And now once we've canceled.
See me canceling now? I still haven't taken the limit. Strictly speaking, this is my bad. I should have limit still there, but I'm just putting it in now. Any better late than never. So negative x plus 2 on top. Cool. Now we're plugging in a 3. So negative 5 on top. 9, 3 plus 3 is 6. Let's just put a little smiley face on the side there. Yeah. Almost an 11-minute problem. It's a 9-minute problem.
That flew by,
Yeah.
so much fun.
Yeah, I know. Took 9 minutes. This is why we need this extra class, because problems take like 10 minutes each to do. What do you think if that were like tomorrow's Do Now quiz? You could do it? Yeah, it is not going to be tomorrow on the Do Now quiz, because I'm going to construct a Do Now quiz that everybody can do. But the next day, okay? I think this is for me, I think it's the most difficult one. Some people think like trig identities or like we'll do that later are the most difficult. I think this is so. If this feels hard, that's correct, okay? You know, don't like be like, oh my gosh, this is only week 2, I'm gonna die the whole year long. Like some things are hard even week 2, but that doesn't mean the whole year is gonna get even harder. It doesn't mean that. Alrighty, so what did you learn today? Talk to your neighbor.
I want to hear everything. Yes, sir.
About math.
Okay, what does that entail?
Yeah.